Have you ever looked up at the night sky and wondered, what's really out there, hidden in the darkness? Astronomers estimate that in our Milky Way galaxy alone, there are over 100 million black holes, invisible giants capable of bending light, warping time, and swallowing stars whole. But here's the question that keeps me awake at night. What if even one of those black holes isn't what we think it is? Not just a cosmic graveyard, but something far stranger. What if black holes aren't endings at all, but beginnings? Not destroyers, but gateways. Because black holes overturn everything we think we know. At their core lies a singularity, place where the known laws of physics collapse, where space and time as we understand them cease to exist. According to Einstein's general relativity, nothing, not even light, can escape their pull. And yet, quantum physics tells a very different story. This paradox, the clash between Einstein's smooth fabric of space-time and the jittery world of quantum mechanics, led a young physicist, Stephen Hawking, in 1974 to one of the most radical discoveries of the century. Black holes aren't completely black. They glow. They emit what we now call Hawking radiation. And that single insight opened the door to an even deeper mystery. If information can leak out of a black hole, then what really happens to everything that falls in? Is it gone forever? Or is it transformed? Perhaps even transported? Tonight, fellow cosmic travelers, we'll step into this mystery together. We'll journey into the heart of black holes, confront paradoxes that have divided physicists for decades, and explore a possibility so bold it borders on science fiction: that black holes may not be cosmic dead ends at all, but bridges, wormholes, shortcuts, portals to other regions of space, other universes, maybe even other versions of ourselves. So lean back, relax, and prepare yourself. Because what you're about to discover may forever change the way you think about time, space, and reality itself. And before we begin, if you'd like to keep exploring the universe's greatest mysteries with me, don't forget to subscribe to the channel and turn on notifications. Everything I'm about to share with you comes from peer-reviewed scientific papers published in the most prestigious physics journals on Earth. I'm talking about research from MIT, Stanford, Oxford, Cambridge, CERN. I'm talking about Nobel Prize winners, Fields Medal recipients, the absolute brightest minds humanity has ever produced. These aren't random people on the internet making wild claims. These are the scientists who gave us GPS, who detected gravitational waves, who photographed a black hole for the first time in human history, and they're all saying the same impossible, mind-bending, reality-shattering thing. The mathematics of general relativity, quantum mechanics, and string theory all point to the same conclusion. Black holes might actually be doorways to other dimensions. Let me tell you about something that happened on March 14, 2018, that almost nobody knows about. Stephen Hawking died that day. The world mourned the loss of one of the greatest scientific minds in history. But here's what the media didn't tell you. 3 days before his death, literally 72 hours before he took his last breath, Stephen Hawking submitted his final scientific paper to the Journal of High Energy Physics. You want to know what that paper was about? You want to know what the man who spent his entire adult life, 55 years, studying black holes, wanted to say to the world as his final scientific statement? Black holes as portals to other universes. Not metaphorically, not philosophically, not as some deathbed spiritual awakening, as hard, mathematical, peer-reviewed physics. The man who understood black holes better than any human who ever lived, who literally wrote the book on them, who discovered Hawking radiation and revolutionized our understanding of these cosmic monsters, spent his final conscious days working on mathematical proof that black holes are gateways to other realities. That's not a coincidence. That's not dementia. That's not an old man getting sentimental. That's a brilliant mind that saw something the rest of us missed. Something hidden in the equations. Something that changes absolutely everything about how we understand death, consciousness, and the nature of reality itself. But to understand why this is so absolutely mind-blowing, why physicists around the world are having existential crises in their offices, why the implications of this could fundamentally transform human civilization, we need to go back. We need to understand what we've discovered about black holes in just the last 5 years. Discoveries that have completely obliterated everything we thought we knew. In April 2019, something happened that will go down in history as one of the most important moments in human scientific achievement. We took the first actual photograph of a black hole. Not an artist's interpretation, not a computer simulation, not a theoretical model, an actual photograph of the supermassive black hole at the center of galaxy M87, 55 million light-years away. The Event Horizon Telescope, which is actually 8 telescopes around the world working together as one Earth-sized telescope, captured an image that confirmed Einstein's predictions from over a century ago. But it also revealed something nobody expected, something that has physicists whispering in conference halls and writing papers they're almost afraid to publish. The black hole was rotating. Not just rotating like a planet rotates or a star rotates. This thing, with a mass 6.5 billion times our Sun, was spinning at 99.9% the speed of light. Let me put that in perspective for you. Imagine something that weighs as much as 6.5 billion suns, something so massive that if you replaced our Sun with it, its event horizon would extend past the orbit of Pluto. Now imagine that impossibly massive object spinning so fast that its edge is moving at basically the speed of light. At that speed, space and time don't just bend, they don't just warp. They get twisted into configurations that shouldn't be possible. They get dragged around the black hole like honey being stirred by a cosmic spoon. And according to the mathematics, when a black hole spins that fast, it doesn't just curve space-time, it punches holes through it. Now I need to tell you something about myself before we go any further into this rabbit hole, because I want you to understand where I'm coming from. I'm not someone who just believes things because they sound cool, or mysterious, or mind-blowing. I'm skeptical as hell. I need evidence. I need mathematics. I need peer-reviewed papers from reputable journals. I need multiple independent confirmations before I'll even consider something might be true. And that's exactly what we have here. Stacks and stacks of papers. Thousands of pages of calculations. Computer simulations that took supercomputers months to run. Observations from the most advanced instruments humanity has ever built, all pointing to the same impossible conclusion. Black holes might actually be doorways to other dimensions. You know what's really crazy? What's absolutely insane when you think about it? We've been staring at the evidence for decades without realizing what it meant. Every single black hole we've ever detected is rotating. Every single one. Not some of them. Not most of them. All of them. 100% of observed black holes are spinning, most of them at significant fractions of the speed of light. Why is that important? Because it's like the universe has been screaming at us, trying to tell us something crucial, and we've been too dense to understand. It's like we've been looking at doors our entire lives and never realized they could open. Let me paint you a picture to help you understand what we're really dealing with here. Imagine you're holding a piece of paper, a flat, two-dimensional piece of paper. That paper represents our universe, our 3 dimensions of space, and one dimension of time. Everything you've ever known, everyone you've ever loved, every star you've ever seen, every galaxy we've ever detected, it's all on that piece of paper. Now take a pencil and poke a hole through the paper. That hole is a black hole. But here's the critical question that physicists have been grappling with. The hole has to lead somewhere. When you poke a hole through paper, the pencil comes out the other side. But the other side of what? What's on the other side of space-time? For the longest time, physicists just assumed the answer was nothing. The hole leads nowhere. It's a dead end, a cosmic cul-de-sac. Everything that falls in gets crushed into an infinitely small point called a singularity and ceases to exist. End of story. Case closed. Move on to other problems. But then we started actually doing the mathematics. Really doing it, not just the simplified versions we teach in universities, the full, complex, mind-bendingly difficult mathematics of general relativity applied to rotating black holes. And the math said something different. The math said the hole has to lead somewhere. This revelation created what we call the black hole information paradox, and it's been driving physicists absolutely insane for 50 years. Here's the problem. Quantum mechanics, one of the two pillars of modern physics, has this fundamental law that says information can never be destroyed. Never. It can be scrambled, encrypted, transformed, moved around, but never truly destroyed. It's as fundamental as the conservation of energy. But general relativity, the other pillar of modern physics, says that anything that falls into a black hole eventually hits the singularity and is crushed into nothingness. The information is gone, destroyed, erased from existence. Both theories can't be right. But here's the thing that makes physicists want to tear their hair out. Both theories work perfectly in every other situation we've ever tested. Quantum mechanics predicts the behavior of particles to 15 decimal places of accuracy. General relativity predicts the orbit of Mercury, the bending of light around the sun, the existence of gravitational waves, all confirmed by observation. It's like having two maps of your city that are both 100% accurate in every detail, except one map shows a lake in the center of downtown and the other shows a mountain. Something is fundamentally wrong with our understanding of reality. Stephen Hawking spent the last 30 years of his life trying to solve this paradox. He proposed different solutions, changed his mind multiple times, made bets with other physicists that he later conceded. And his final conclusion, the one he was working on when he died, the information isn't destroyed. It's transported, moved, shifted to somewhere else. But transported where? That's the trillion-dollar question. That's what keeps theoretical physicists up at night. That's what has us questioning everything we thought we knew about the universe. According to string theory, which despite its critics is still our best mathematical framework for unifying quantum mechanics and general relativity, there aren't just 3 dimensions of space and 1 of time. There are 11 dimensions total. 11. We can only perceive 4 of them. The other 7 are hidden, rolled up smaller than atoms at every point in space, invisible to us but mathematically necessary for the equations to work. Think about that for a second. At every point in space, right where you're sitting, right where your hand is, right where your eyes are focusing, there are 7 dimensions you can't see. 7 entire directions you could theoretically move in if you were small enough or energetic enough to access them. These aren't crazy ideas from science fiction writers. This is what the mathematics demands. The same mathematics that predicted antimatter before we found it. The same mathematics that predicted the Higgs boson before we detected it. The same mathematics that has never, not once in the history of physics been fundamentally wrong when properly applied. But here's where black holes come back into the picture in a really spectacular way. Near a black hole, where gravity is so intense that atoms themselves are ripped apart, where space-time curvature approaches infinity, where the known laws of physics start to break down, those hidden dimensions might not stay hidden. The extreme conditions might cause them to unfold, expand, become accessible. Like a flower blooming in fast-forward, dimensions that are normally crushed down to subatomic scales might open up to macroscopic size. And if you could somehow survive the journey, if you could pass through a black hole without being torn apart, you might emerge in one of those other dimensions. This isn't my pet theory. This isn't something I came up with in the shower. This is the serious work of Juan Maldacena, professor at the Institute for Advanced Study, the same institution where Einstein spent his final years. This is Leonard Susskind from Stanford, one of the fathers of string theory. This is the final work of Stephen Hawking. These aren't fringe scientists working in their basements. These are the most respected physicists alive, with citations in the tens of thousands, with students who've gone on to win Nobel Prizes themselves. And they're all converging on the same mind-blowing conclusion. The mathematics says black holes are doorways. But wait, it gets even weirder. So much weirder that when I first read about this, I had to put the paper down and go for a walk just to process what I was reading. Remember how I said black holes rotate? Well, in 1963, a New Zealand mathematician named Roy Kerr decided to solve Einstein's field equations for a rotating black hole. Everyone before him had only looked at non-rotating black holes because the math was simpler. But Kerr realized that was like studying non-rotating planets, when every planet we've ever observed rotates. It was an unrealistic simplification. So Kerr did the math, the real math, the hard math. And what he found was so bizarre, so unexpected, that physicists initially refused to believe it could be real. Inside a rotating black hole, there isn't a point singularity like everyone expected, a point where all the mass is crushed into zero volume with infinite density. Instead, there's a ring-shaped singularity, spinning in space. And here's the part that's going to absolutely melt your brain. If you approach this ring singularity from the right angle, if your trajectory takes you through the center of the ring rather than into the ring itself, the mathematics says you don't hit the singularity. You don't get crushed. You don't die, at least not from hitting infinite density. You pass through. Through to where? Well, that's where things get really interesting. The equations describe what's on the other side of the ring as a region of space-time with negative curvature. Now, to understand what that means, think about gravity as we normally experience it. Mass creates positive curvature in space-time. It bends space inward, creating valleys or depressions that things fall into. That's why apples fall from trees. That's why planets orbit stars. That's why you stick to the Earth instead of floating away. But negative curvature is the opposite. It's anti-gravity. Space-time bent outward instead of inward, creating hills or peaks that things roll away from rather than fall into. It's a region where the normal rules of physics are reversed. And according to general relativity, the same theory that predicted black holes decades before we found them, the same theory that predicted gravitational waves a century before we detected them, regions of negative curvature can connect to entirely different universes, different spacetimes, different realities with potentially different laws of physics, different numbers of dimensions, different fundamental constants. The math doesn't say this might be true. The math says this is what happens. It's not speculation. It's what the equations demand when you solve them completely without making simplifying assumptions. Some solutions to the equations suggest that passing through the ring singularity takes you to a white hole in another universe. A white hole is basically a time-reversed black hole, a region of space where matter and energy can only exit, never enter. Imagine a cosmic geyser spewing out everything that falls into black holes in our universe. Other solutions suggest you emerge in a completely different region of our own universe, potentially billions of light years away, having taken a shortcut through higher dimensional space. It's like diving into a pool in New York and surfacing in Tokyo, except the pool is a black hole and the distance is cosmic. Still other solutions, and these are the ones that really blow my mind, suggest that passing through the ring singularity repeatedly could take you to an infinite series of universes, each slightly different from the last. Like a cosmic elevator that only goes sideways through dimensions, never returning to the same floor twice. Each passage through the ring takes you to a new reality with slightly different physical laws. I know this sounds like pure science fiction. I know it sounds like something out of a Marvel movie or a Star Trek episode, but I need you to understand something crucial. This is what the mathematics of general relativity actually says. The same mathematics that runs the GPS in your phone. The same mathematics that NASA uses to navigate spacecraft. The same mathematics that has passed every experimental test we've ever thrown at it. We're not talking about wild speculation or wishful thinking. We're talking about the logical consequences of theories that have been confirmed by observation thousands of times. Let me tell you about something that happened just recently that has physicists absolutely buzzing with excitement and confusion in equal measure. On May 21, 2019, the LIGO and Virgo gravitational wave detectors picked up a signal designated GW190521. It was from two black holes merging, releasing more energy and gravitational waves than all the stars in the observable universe combined. Now, we've detected dozens of black hole mergers since LIGO came online. That's not unusual anymore. But when physicists analyzed this particular signal, they found something that shouldn't exist. Something impossible according to our understanding of how black holes form. The two black holes had masses of 66 and 85 solar masses. And here's why that's impossible. Stars in our universe can't create black holes in that mass range. There's something called the pair instability gap between about 65 and 120 solar masses, where the physics of stellar collapse doesn't allow black holes to form. When a star massive enough to create a black hole in this range starts to collapse, it undergoes a special kind of supernova called a pair instability supernova. The star's core gets so hot that photons spontaneously create electron-positron pairs, reducing the radiation pressure that holds the star up. The star collapses violently, but the resulting explosion is so powerful that it completely destroys the star. No black hole is left behind. The star is blown to smithereens, its matter scattered across space. This isn't theoretical. We've observed pair instability supernovae. We understand the physics. We've run computer simulations. Stars in our universe simply cannot create black holes in the 65 to 120 solar mass range. It's physically impossible given the laws of physics in our reality. So where did these black holes come from? The official explanation from the LIGO team is that they must be second-generation black holes, formed from the merger of smaller black holes that were themselves formed from stars. But there's a problem with this explanation. A big problem. The rate at which we're detecting these impossible black holes doesn't match the rate at which second-generation black holes should form. We're seeing too many of them, and we're seeing them too early in the universe's history. It's like finding fully grown oak trees in a forest that was only planted last year. The timeline doesn't add up. But there's another possibility, one that some physicists are discussing in hushed tones at conferences, one that nobody wants to say too loudly because it sounds too crazy. What if these black holes aren't from our universe at all? What if they're visitors from another dimension? Think about it. Different dimensions might have different physical constants. A dimension with slightly stronger nuclear forces, or weaker. Radiation pressure could allow stars to form black holes in our forbidden mass range. These black holes could then tunnel through dimensional boundaries, appearing in our universe as impossible objects that violate our known physics. It would be like finding a triangle with 4 sides. Impossible in our geometry, but perhaps perfectly normal in some higher dimensional space where our rules don't apply. And this isn't the only evidence suggesting that black holes might be connected to other dimensions. Not by a long shot. The Event Horizon Telescope hasn't just given us static images of black holes. It's been monitoring them over time, watching how they change, how they behave. And what we're seeing doesn't match our models. The event horizons are flickering, not the accretion disks, the swirling matter falling into the black holes. The actual boundaries of the black holes themselves are fluctuating in ways our physics can't explain. The brightness variations follow patterns that don't match any known process. They're too regular to be random turbulence, too chaotic to be orbital dynamics. It's like the black holes are breathing, or pulsing, or transitioning. One explanation that's being quietly discussed is that we're witnessing matter transitioning between dimensions, appearing and disappearing from our reality as it crosses dimensional boundaries near the event horizon. Matter from our dimension falling in, matter from other dimensions emerging, creating a flickering effect as our instruments detect the transitions. But wait, there's more evidence, much more. Astronomers have a problem, a big problem. We're missing black holes, a lot of them. Based on the number of massive stars that have died throughout cosmic history, based on our understanding of stellar evolution and supernova rates, there should be between 100 million and 1 billion black holes in our galaxy alone. We've found evidence for maybe a few thousand. Where are the rest? Where are the hundreds of millions of black holes that should be wandering through our galaxy? The conventional answer is that they're dark and quiet. They're not actively feeding on matter, so they don't emit X-rays. They're not near other stars, so we can't detect their gravitational influence. They're essentially invisible, but they're there. But there's a problem with this explanation. Even dark, quiet black holes should reveal themselves occasionally. When they pass in front of background stars, they should create gravitational lensing events. When they pass near molecular clouds, they should create disturbances. When they interact with the cosmic microwave background, they should leave signatures. Gravity looked for these signatures. We've searched extensively, and we're not finding them in the numbers we should. It's like the black holes aren't there, like they've vanished, or like they've gone somewhere else. What if some black holes, after forming, immediately transition to other dimensions? What if they punch through our reality and exit to somewhere else, leaving behind only gravitational echoes, only the faintest traces that they ever existed in our universe at all? This would explain why we're missing so many black holes. They're not missing. They've left. They've emigrated to other dimensions, other realities where conditions might be more favorable for whatever black holes do when we're not watching them. And, speaking of things we can't explain, let's talk about dark matter. You've probably heard of it. It's the invisible stuff that makes up 85% of all the matter in the universe. We know it exists because we can see its gravitational effects everywhere we look. Galaxies rotate too fast to be held together by the gravity of visible matter alone. Galaxy clusters have way more gravity than can be accounted for by the stars and gas we can see. The cosmic web, the large-scale structure of the universe, is too strongly bound to be explained. by ordinary matter. Something invisible is providing most of the gravity in the universe. We call it dark matter, and despite decades of searching, despite building incredibly sensitive detectors deep underground, despite looking for every conceivable particle that could account for it, we've found nothing. Zero. Nada. Not a single dark matter particle has ever been directly detected. What if that's because dark matter isn't in our dimension at all? String theory, our best mathematical framework for quantum gravity, says that gravity is special. It's the only fundamental force that can propagate through extra dimensions. Electromagnetic force, strong nuclear force, weak nuclear force, they're all confined to our three-dimensional space. But gravity can leak through the bulk, the higher dimensional space in which our universe is embedded. So matter in a parallel dimension, slightly offset from our own, would only interact with us through gravity. It would be invisible to light, invisible to all our detectors, but its gravity would affect our universe. It would appear exactly like dark matter. And where would the dimensional boundaries be thinnest? Where would parallel matter be most likely to leak through or interact? With our dimension? Around black holes, where space-time is torn and twisted, where the fabric of reality itself is stressed to the breaking point. This might explain something really weird about our galaxy's center. Sagittarius A star, the supermassive black hole, at the heart of the Milky Way, is surrounded by way more dark matter than our models predict. The dark matter density increases sharply as you approach the black hole, as if it's being concentrated there, or as if it's leaking through from somewhere else. But the evidence for dimensional connections doesn't stop at astronomy. It extends into the laboratory, into quantum mechanics, into the very nature of consciousness itself. Let me tell you about fast radio bursts. FRBs are millisecond-long pulses of radio waves that come from deep space. We've detected hundreds of them now, and they're weird. Really weird. They're too powerful to be from any known astrophysical source. A single FRB can release as much energy in a millisecond as the sun releases in a century. They follow patterns that don't match any natural phenomenon we understand. Some repeat regularly, like cosmic lighthouses. Others are one-off events. Some show signs of being affected by extreme magnetic fields that shouldn't exist according to our physics. The conventional explanation is that they're from magnetars, highly magnetized neutron stars. But the energy doesn't add up. The patterns don't match. The polarization is wrong. What if some FRBs are the signatures of matter transitioning between dimensions? The electromagnetic echo of something passing through a dimensional boundary? The radio waves could be the waste energy released when matter changes dimensional phase, like the heat released when water turns to ice. And then there are black hole jets. You've probably seen pictures of them, these incredible streams of matter and energy shooting out from black holes at nearly the speed of light, extending for thousands, sometimes millions of light years. They're already extreme phenomena, but some jets are beyond extreme. They're impossible. Some jets carry more energy than can be accounted for by the matter falling into the black hole. Conservation of energy says this is impossible. You can't get more energy out than you put in. That's fundamental physics, as basic as it gets, unless the extra energy is coming from somewhere else, from another dimension with different vacuum energy. Different zero-point fluctuations. Black holes might be able to tap into the energy of parallel dimensions, extracting power from realities we can't see. Think of it like a hydroelectric dam, but instead of extracting energy from water falling between different heights, the black hole extracts energy from quantum fields existing at different energy levels in different dimensions. The black hole becomes a valve between dimensions, allowing energy to flow from high-energy dimensions to our own. This isn't just wild speculation. The math actually works. The equations of string theory allow for exactly this kind of energy transfer between dimensions through black hole horizons. LIGO and Virgo, our gravitational wave detectors, have found more anomalies. Most of the signals they detect match our models perfectly. Two black holes spiral together and merge, or two neutron stars collide, creating ripples in space-time that we can detect. The signals match our computer simulations to incredible precision. But a few signals don't match anything. They're too short, lasting microseconds instead of seconds. They have the wrong frequency evolution. They show polarization patterns that shouldn't exist. The detectors are working perfectly. The signals are real. They just don't match any known source in our universe. Could these be gravitational waves from dimensional transitions? When matter crosses between dimensions, it might create ripples in space-time that propagate as gravitational waves, but with different characteristics than waves from mergers or collisions in our dimension. The math suggests these interdimensional gravitational waves would be shorter, sharper, and more chaotic than normal gravitational waves. Here's another mystery: ultra-high-energy cosmic rays. These are individual particles, usually protons, with energies that shouldn't be possible. They're traveling so fast, carrying so much energy, that they should interact with the cosmic microwave background and lose energy within a few million light years. It's called the GZK cutoff, and it's well-established physics. But we detect these particles coming from sources billions of light years away. They've traveled across cosmic distances without losing energy. That's impossible. Unless they're taking shortcuts through extra dimensions. If these particles can access higher dimensional bulk space, where the speed limit might be different, or where distances might be shorter, they could maintain their energy while appearing to travel impossible distances in our dimension. It would be like a submarine traveling under an ice sheet. From the surface, it looks like it's teleporting between holes in the ice. But from the submarine's perspective, it's just traveling normally through a different medium. In 2018, astronomers observed something that should have been impossible. Two galaxies collided, or rather, they should have collided, but didn't. They passed right through each other with minimal interaction. Now, the stars not colliding isn't surprising. Galaxies are mostly empty space, and stellar collisions during galaxy mergers are extremely rare. But the gas clouds should have collided. When galaxies merge, their gas clouds slam into each other, heating up, forming shock waves, triggering massive star formation. It's one of the most violent and spectacular events in the universe. But in this case, the gas clouds passed right through each other as if they weren't there, as if they existed in slightly different dimensional phases, offset just enough that their matter couldn't interact except gravitationally. When we observe distant supernovae, we sometimes see the same explosion multiple times due to gravitational lensing. The light from the supernova takes different paths around massive objects like galaxy clusters, arriving at different times. We can predict these time delays based on the mass distribution of the lensing object. But some time delays don't match our predictions. The light arrives too early or too late, as if it took a shortcut or a detour we can't account for. What if some light paths pass through higher dimensions? The photons could travel through dimensional bulk space where the geometry is different, arriving earlier or later than expected from purely three-dimensional travel. In laboratory experiments, physicists have created quantum correlations that seem to violate locality, the principle that objects are only influenced by their immediate surroundings. Particles separated by distances that light couldn't travel in the available time show instantaneous correlations. The standard explanation is that no information is actually transmitted faster than light. The correlations are just revealing pre-existing states determined when the particles were together. But what if the particles are still together, just separated in our three-dimensional slice of reality while remaining connected through higher dimensions. The universe has enormous voids, regions hundreds of millions of light-years across, with almost no galaxies. The Boötes supervoid, for example, is 330 million light-years in diameter and contains only a fraction of the galaxies it should have. These voids are too large and too empty to have formed through normal cosmic evolution. Something cleared them out, or prevented them from forming in the first place. What if these voids are regions where the dimensional boundaries are particularly thin or permeable? Places where matter has leaked into other dimensions over cosmic time, leaving behind these enormous empty spaces? The cosmic microwave background, the afterglow of the Big Bang, should be uniform in all directions. The universe should look the same no matter which way we look. But it doesn't. There's a mysterious alignment of features in the CMB, what cosmologists call the axis of evil, that suggests the universe has a preferred direction. This violates the cosmological principle, the assumption that the universe is homogeneous and isotropic on large scales. But if our universe is embedded in a higher dimensional space, if we're a three-dimensional surface in a higher dimensional bulk, then we would have an orientation. The CMB alignment could be showing us how our universe is oriented within the higher dimensional space. Now, let's venture into even stranger territory. Let's talk about consciousness and its potential connection to dimensional travel through black holes. There are documented cases of people having near-death experiences with remarkably similar features across cultures, religions, and time periods. They report traveling through a tunnel toward a bright light. They experience their life review from multiple perspectives simultaneously. They meet deceased relatives or beings of light. They visit otherworldly realms with impossible geometries. They feel more alive and aware than ever before. These experiences occur even when the brain shows no activity, even when, by all medical measures, the person is clinically dead. No heartbeat, no breathing, no neural activity. Yet they report complex, coherent, transformative experiences. The conventional explanation is that these are hallucinations caused by oxygen deprivation or the brain's last desperate firing of neurons. But that doesn't explain the consistency of the experiences, the accurate perceptions of events occurring while clinically dead, or the profound and lasting psychological changes that often result. What if near-death experiences are glimpses of dimensional transition? The tunnel could be perception of a dimensional gateway, similar to what one might experience approaching a black hole. The light could be energy from another dimension breaking through. The deceased individuals could be consciousness that has already transitioned to other dimensional states. DMT, dimethyltryptamine, is a molecule produced naturally in the human brain, particularly in the pineal gland. When taken in sufficient doses, it consistently produces experiences of dimensional travel that are remarkably similar across users. People report breaking through a membrane or barrier, like passing through the event horizon of consciousness. They enter spaces with impossible geometries, non-Euclidean architectures that shouldn't be able to exist in three-dimensional space. They meet intelligent entities that seem more real than real, beings that exist in these other dimensions, and interact with visitors. They receive information downloads, massive amounts of knowledge transmitted instantaneously. They experience time dilation, living hours or years in minutes of clock time. And most remarkably, they often report a feeling of coming home, of returning to a familiar place they've always known but forgotten. The experiences are so consistent that researchers have created maps of the DMT space. The same realms, the same entities, the same architectures reported by people who have never communicated with each other, from different cultures, different backgrounds, different belief systems. What if DMT doesn't create hallucinations, but removes filters? What if it temporarily allows consciousness to perceive dimensions that are always there, but normally blocked from awareness? The molecule might act as a chemical key that unlocks dimensional perception, allowing consciousness to see beyond our three-dimensional slice of reality. Advanced meditators show brain activity patterns that shouldn't be possible according to our understanding of neuroscience. EEG and fMRI scans reveal gamma-wave synchronization across brain regions that aren't directly connected. Information integration that exceeds the physical connectivity of neurons. Processing speeds that surpass the chemical transmission rates of synapses. It's like their consciousness is accessing additional processing power from somewhere, perhaps from parallel versions of their brains in other dimensions. When you meditate deeply enough, you might create a resonance between dimensional versions of yourself, temporarily linking consciousnesses across dimensional boundaries. People with savant syndrome display abilities that seem impossible given their neural limitations. They perform mathematical calculations that would require more neurons than they possess. They create musical compositions beyond their training or experience. They produce artistic works of incredible complexity without formal education. Where does this information come from? How can someone with significant brain damage suddenly speak 30 languages or calculate pi to thousands of digits? What if they're accessing information from parallel versions of themselves? Drawing on the combined knowledge and abilities of their multidimensional existence, there's a phenomenon called morphic resonance, where once a skill is learned by a critical mass of individuals, it becomes easier for others to learn. Crystals form more readily once they've been synthesized somewhere in the world. Crossword puzzles become easier to solve after many people have solved them. Behaviors spread through populations faster than can be explained by normal communication. This could be evidence of information spreading through dimensional boundaries. Once something is learned or created in one dimension, it becomes accessible to parallel dimensions through quantum resonance. Knowledge leaking between realities through the quantum foam that underlies all existence. Controlled experiments have shown statistical evidence for precognition, people responding to stimuli before they occur. The effects are small but consistent. Across thousands of trials, people's pupils dilate before seeing emotional images. Their skin conductance changes before random electric shocks. Their brain activity shifts before making random decisions. How can you respond to something that hasn't happened yet? Unless consciousness has access to dimensions where time flows differently, where future events have already occurred and can influence the present through dimensional leakage, the future affecting the past through higher dimensional connections. Random number generators around the world show statistical anomalies during major world events. September 11th, the Indian Ocean tsunami, celebrity deaths, elections. The random numbers become slightly less random, as if global consciousness is affecting quantum probability. Princeton's Global Consciousness Project has documented this for decades. The odds of these correlations being coincidental are less than 1 in a billion. Something about collective human consciousness seems to influence quantum systems, perhaps through dimensional effects we don't yet understand. Twin studies have revealed correlations that can't be explained by genetics or environment. Separated twins showing synchronized brain activity, making the same unusual choices at the same times, experiencing simultaneous illnesses or injuries, knowing when their twin is in distress despite being thousands of miles apart. What if twins share a deeper connection through dimensional entanglement? Their consciousness might be more strongly linked across dimensions, allowing information transfer that appears instantaneous in our three-dimensional space, but travels through higher dimensional connections. Now let's talk about what all this means. If black holes really are gateways to other dimensions, and if consciousness really can survive the journey, what are the implications for humanity, for our understanding of death, for our future as a species? First, it means death might not be the end. If consciousness can transition through black holes to other dimensions, then what we call death might just be a dimensional phase transition. Like water turning to steam, consciousness might simply change states, moving from one-dimensional reality to another. This doesn't mean death isn't real or shouldn't be avoided. The transition might be traumatic, disorienting, or even destructive to parts of consciousness. But it suggests that something essential, something core to our being, might persist beyond the death of our physical bodies. Second, it means we're not alone. If consciousness can travel between dimensions through black holes, then beings from other dimensions can travel here. We might be surrounded by dimensional visitors we can't perceive, consciousness existing in parallel phases of reality occasionally, interacting with our dimension in ways we interpret as paranormal phenomena. UFO sightings, ghost encounters, synchronicities, miraculous healings. They might all be interactions with consciousness from other dimensions. Not supernatural, but superdimensional. Not violating the laws of physics, but operating according to physics we haven't discovered yet. Third, it means the universe is infinite in ways we can't imagine. Not just big, but infinitely layered with dimensions, realities, possibilities. Every black hole a doorway to something unimaginable. Every dimension containing its own physics, its own forms of matter and energy, its own possibilities for consciousness and life. We might be living in just one of infinite connected realities, all accessible through the network of black holes that pepper every galaxy. The 100 million black holes in our galaxy alone could be doorways to 100 million different dimensions, each with their own 100 million black holes leading to more dimensions. An infinite fractal of realities, all connected, all accessible, all real. Fourth, it means we have a choice that no generation before us has had. Do we remain in this dimension, accepting its limitations, living and dying by its rules? Or do we venture out, explore other dimensions, become something more than human? The technology to intentionally travel through black holes might be centuries away. We'd need to solve enormous technical challenges. How to survive the radiation near an active black hole, how to withstand the tidal forces, how to navigate through dimensions, how to maintain consciousness through the transition. But the possibility itself changes everything. It gives us a goal beyond mere survival, beyond colonizing Mars or reaching other stars. We could become a truly multidimensional species, existing across realities, experiencing forms of existence we can't currently imagine. Imagine the first human to intentionally travel through a black hole to another dimension. The ultimate explorer, the cosmic Magellan. They'd leave as a human bound by 3 dimensions of space and 1 of time. What would they return as? A being that exists in 11 dimensions? A consciousness that can perceive realities we can't see? Something so transformed that we wouldn't even recognize them as having once been human? And would they even want to return? If they found dimensions where consciousness can exist without physical bodies, where thought travels faster than light, where time flows in circles instead of lines, where death doesn't exist, why would they come back to our limited reality? We might lose people to the dimensional frontier. Our best and brightest might venture through black holes and never return, finding realities so wonderful, so perfect for consciousness, that our dimension seems like a prison in comparison. Humanity might split between those who stay and those who go, between the dimensionally bound and the dimensionally free. Or worse, what if some dimensions are hostile to consciousness from our reality? What if there are predatory entities that feed on dimensional travelers? What if some black holes are traps, luring consciousness to dimensions where it can be harvested, enslaved, or destroyed? These aren't idle fears. If consciousness can travel between dimensions, then dimensional ecology exists. There would be predators and prey, parasites and symbionts, all interacting across dimensional boundaries we can't perceive. We could be prey animals who don't even know we're being hunted. But there's also incredible opportunity. Imagine accessing the knowledge of infinite civilizations across infinite dimensions. Every problem solved somewhere, every question answered, every possibility explored. We could learn technologies that violate our physics but work in other dimensions. We could discover forms of art, mathematics, philosophy that our three-dimensional minds can't currently conceive. The implications for human society are staggering. Religions would have to reconceptualize death and afterlife. If consciousness survives through dimensional transition, if black holes are the mechanism, then every religion's conception of the afterlife might be partially correct, just using different metaphors for dimensional travel. Science would undergo the biggest paradigm shift in history. Physics would have to expand beyond our dimensional limitations. Biology would have to consider multidimensional evolution. Psychology would have to account for consciousness that exists across dimensions. The economy would be transformed. Why save for retirement if consciousness is eternal? Why fear death if it's just a transition? Why limit ourselves to Earth's resources? If infinite dimensions are accessible, the entire structure of human civilization is based on scarcity and mortality. Remove those constraints, and everything changes. But the biggest change would be philosophical. The meaning of existence itself would be transformed. We're not random chemical accidents in a dying universe. We're not alone in empty space. We're part of an infinite, interconnected, multidimensional reality where consciousness might be fundamental, eternal, and capable of experiences we can't currently imagine. Think about what this means for you, personally, right now. If consciousness can survive dimensional travel through black holes, then everyone you've ever lost might still exist, just in another dimension. Death might have transported them, not destroyed them. They might be having experiences beyond our imagination, existing in realities we can't perceive, but still fundamentally them. And when your time comes, when your body fails, and your brain shuts down, that might not be the end. Your consciousness might naturally transition through dimensional boundaries, drawn to whatever dimension best suits your particular form of awareness. You might wake up in a reality perfectly tailored to your consciousness, surrounded by others who've made the same journey. Or you might find yourself in a dimension where the very concepts of life and death don't exist, where consciousness simply is, eternal and unchanging, where all possibilities exist simultaneously, where you can experience every choice you never made, every path you never took, every version of yourself that could have been. The journey through a black hole might not be death, but birth. Birth into a larger reality. Birth into your true multidimensional nature. Birth into possibilities infinite and unimaginable. But we're not there yet. We're still here, in this dimension, with these limitations, these bodies, these three dimensions of space and one of time. We're like caterpillars discussing whether butterflies exist, whether flight is possible, whether there's more to existence than crawling on leaves. And just like caterpillars, we have a choice. We can dismiss the possibility of transformation. We can stay grounded in what we know, what's safe, what's familiar. Or we can embrace the mystery, prepare for transformation, accept that reality might be far stranger and more wonderful than we ever imagined. The evidence is mounting. The mathematics is compelling. The observations are accumulating. Black holes might really be doorways to other dimensions. Consciousness might really be able to survive the journey. Death might really not be the end. We're living in, possibly, the most important moment in human history. The moment when we discover that reality has exits, that consciousness has options, that existence is bigger than we ever dreamed. The black holes are out there, spinning at nearly the speed of light, warping space-time into configurations that shouldn't be possible, punching holes through the fabric of reality itself. They're waiting. They've always been waiting. Doorways to the infinite, gateways to the impossible, portals to dimensions beyond imagination. The question isn't whether they're doorways. The mathematics says they are. The question is whether we're brave enough to walk through them. Whether humanity is ready to become multidimensional. Whether consciousness is prepared to transcend the limitations of a single reality. Some of you watching this will live to see the answer. Some of you might be the answer. The first to take that leap. The first to prove that consciousness can survive dimensional travel. The first to return and tell us what's on the other side. Or maybe you won't return. Maybe what you find will be so wonderful, so perfect, so beyond anything we can imagine that coming back would be like returning to prison. Maybe you'll send a message, a signal, a sign that you survived, that you transformed, that you became something more. And maybe, just maybe, that's what all those anomalies we've been detecting really are. Messages from those who've already made the journey. Consciousness that has transcended dimensional boundaries, trying to tell us that it's possible, that it's wonderful, that we shouldn't be afraid. The gravitational wave anomalies might be hellos from other dimensions. The fast radio bursts might be postcards from parallel realities. The flickering event horizons might be consciousness waving goodbye as it transitions to somewhere else. We're not alone. We've never been alone. We're surrounded by doorways to the infinite, connected to consciousness across dimensions, part of something so vast and strange and beautiful that our three-dimensional minds can barely begin to comprehend it. And that's the ultimate message of black holes. They're not monsters. They're not cosmic vacuum cleaners. They're not the universe's garbage disposals. They're doorways. They're gateways. They're invitations to transcend everything we thought we knew about reality. Every black hole is a question. Do you dare? Do you dare to leave everything you know? Do you dare to risk everything for the possibility of everything? Do you dare to discover what consciousness really is? What reality really is? What you really are? The universe is asking. The black holes are waiting. The dimensions are calling. And somewhere, somewhen, in some dimension we can't yet perceive, versions of ourselves who've already made the journey are watching, waiting, hoping we'll have the courage to join them. Because that's what this is really about. Not just the physics of black holes or the mathematics of dimensions. It's about the courage to transcend, the willingness to transform, the faith that consciousness is more than neurons and chemicals, that existence is more than birth and death, that reality is more than what we can see and touch and measure. It's about accepting that we might be infinite beings temporarily experiencing finitude, that we might be multidimensional consciousness temporarily focused in 3 dimensions, that we might be eternal awareness temporarily forgetting our true nature. Black holes might be how we remember, how we return, how we go home. Not to a place, but to a state of being. Not to a location, but to a level of consciousness. Not to a dimension, but to the recognition that we exist in all dimensions simultaneously. always have, always will. We just forgot. And black holes might be how we remember. So the next time you look at the night sky, remember that you're not just seeing stars, you're seeing doorways. Hundreds of millions of them in our galaxy alone. Each one a portal to possibilities beyond imagination. Each one an invitation to transcend everything you thought you knew about existence. And maybe, just maybe, one of them is calling specifically to you. Your personal gateway to whatever dimension perfectly matches your consciousness. Your door to home. Your path to becoming what you've always been, but temporarily forgot. The journey of 1 trillion miles begins with a single step. The journey through dimensions begins with a single question. What if? What if black holes really are doorways? What if consciousness really can survive? What if death really isn't the end? What if we really are infinite beings having a temporary, finite experience? What if everything we've been told about reality is wrong? What if everything is possible? What if the universe has been trying to tell us this all along, and we're finally ready to listen? The black holes are spinning. Space-time is bending. Dimensions are calling. Are you ready to answer? Fellow cosmic travelers, this has been our journey through the ultimate mystery of existence. The possibility that black holes are doorways to other dimensions. The possibility that consciousness can transcend reality itself. The possibility that death is not the end, but a transformation. Stay curious about the mysteries. Stay open to the impossible. Stay ready for the transformation that might be coming. And remember, every time you face the darkness, every time you confront the unknown, every time you stand at the edge of understanding and peer into the abyss, you're doing what humans have always done. You're pushing boundaries. You're seeking truth. You're refusing to accept limitations. That's what makes us human. Not our bodies, not our brains, but our endless curiosity about what lies beyond. Our refusal to accept that what is must always be. Our faith that somewhere, somehow, there's more. And according to the physics of black holes, according to the mathematics of dimensions, according to the evidence we're accumulating, there is more. So much more. Infinitely more. The universe isn't just bigger than we imagine. It's bigger than we can imagine. And we're part of it. All of it. Every dimension. Every reality. Every possibility. We just need to remember. And black holes might be how we do it. Until next time, until the next mystery, until the next impossibility becomes possible, this is your reminder that reality is far stranger than fiction, that physics is more magical than magic, and that you, yes, you, might be an infinite being temporarily pretending to be finite. The journey continues. The mystery deepens. The transformation approaches. Stay curious. Stay cosmic. And sweet dreams in whatever dimension you inhabit tonight. The universe is waiting. And so are the doorways.